Hello and Assalamu alaikum. My name is Fakisha, and in this video we are discussing about Verilog programming and hardware implementation of full adder, full subtractor, 4 cross 1 mux and 1 cross 4D multiplexer or 4 1 cross 4 demux. So we are using Corda software and FPGA hardware in hardware. So this is a simulation. So we are using a Corda software in it. So first of all, this is a multiplexer. This is 4 cross 1 mux in which we have 4 inputs, 2 selection lines, and 1 output. So it is according to the selection inputs that control the output of the from the input. So when the selection is 0 0, the input 0 goes to the output, and if selection is 0 1, and the input 1 goes on the output, and the selection is 1 0, input 2 goes to the output, and when the both of selection line give the one given one, the input 4 or 3 goes on the output. So and in the 4 cross 1 multiplexer, this is a circuit diagram on a gate level. So in demultiplexer, we have one input and we have 4 output. It is the opposite of multiplexer. So we have two selection inputs, selection lines, the same as the 4 cross 1 multiplexer, but the differences of the input and the output, it is opposite to each other. So this is a 1 to 4 channel, that is that are, you can say that these are switches controlled by selection inputs lines. So this is a demultiplexer truth table. After that, this is the full adder. A full adder has a carry in and a carry out. So we have A and B as the input, and we have a carry in also, and sum is the output and carry out is the output. So this is the gate level diagram of full adder circuit. So this is a truth table, that is when we give 0 0 and as a b input, and we have carry in as 0, the sum is 0 and carry out is 0. But one when we have 1 1 as a b input and output is 1, and there is a carry out as a carry in is a 1. So if we have a b and 1 1, so the sum becomes 0 and the carry out becomes 1, and we have 1 0, we have the sum as 0 and we have carry in as 1, and so we have carry out as a 1. So similarly this table continues like that, and in the full subtractor we have a borrow in and a borrow out. Only the difference is of carry in, carry out in some full subtractor and full adder. So similar is the truth table, that is when all the 0 is the output, and when the 0 0 is the input and borrow in is 1, that the difference and borrow out are 1 1. So if I move towards its program in multiplexer, we have module mux, that is output, input 1, input 2, input 3, input 4. Section 1 and section 2, that is written as control 1 and control 2 are written that have been declared. So output is the output out symbol, and input is in 1, in 2, in 2, in 3, in 4, in control 1 and control 2, it is a selection line. So in assignment, we are using assign out. So it will run in parallel all the inputs. So it's a continuous programming. So so in assign out, we are using that in 1 and negation of control 1 and control 2. So in 1 is out when the control 1 and control 2 are 0. So in 2 is out when control or is the or statement. So in 2 is out when control 1 is 0 and control 2 is 1. And 3 is out when control 1 and uh, control 2 is 0. And 4 is out when control 1 and control 2 are both 1. So this is the RTL viewer, the gate level diagram. And then we have this university waveform, that is of mux output. So this is a hardware picture. So then we have demux. Demux is demultiplexer. So we have in one input and 4 outputs, out 1, out 0, that is out 1, out 2, out 3, control and section lines. So over here we have a sign that is 0, and in 1 is out when control 1 and control 2 are 0. Out 1 is with the input 1 is out when control 1 is 0 and control 2 is 1. So in this way, according to the truth table, this coding is done, programming is done. So a full adder program is made, that is A and B and carry in is the input, and C out and sum is the output. So A and B are 2 bits, and carry in and carry out are 1 bit. So we assign the carry out and sum as equal to A plus B and plus carry in. So this is a circuit RTL view of full adder, and this is a waveform of full adder. So then we move on to a full subtractor. So in full subtractor, we have A, B, and borrow in as input and borrow out and subtractor as output. So borrow out and subtract is equal to A minus B minus B. So this is the circuit diagram of RTL view of full subtractor, and this is the full subtractor output waveform. So that was it from this video. Thank you very much for watching.